Okay, so we are going to get a definition of the derivative today. Nope, we're not. We're going to get a definition of the derivative tomorrow. Tricked you.
What? Is he ready to do reading? I'll remember right now. Yeah, for sure. Are we having an assignment today?
Go ahead.
We don't even know what derivatives are. You're not going to tell us till tomorrow, so I would just have an assignment. That's a lot of lot. Oh, man, it's a lot better
All right, so this little definition here summarizes a lot of the things that we were talking about in the last chapter, a lot of the things that we did. And that is that the tangent line to the curve y equals f of x, so nothing fancy there, right? Y equals f of x. At the point, this looks a little bit scary, but it's not, or it shouldn't be. P of a comma f of a, okay? So the point is P, and the x-coordinate is what? A, and the y-coordinate is what you get when you put A into our function. So this is just a fancy way of saying the point x comma y. It's calculus, that's how we roll. Okay, just, get right after it. So the tangent line to the curve at that particular point is the line through the point P. And what we've been sort of working on with the limits is how to find the slope of that line. And so what we're doing is we're basically just using the old-fashioned slope formula, y2 minus y1 over x2 minus x1. But what we want to do is, we talked about this on the very first day of school, we want to have that point get closer and closer together, so that's why we take the limit as the two things as x approaches a. So again, we talked about this way earlier. Like I said, if we start, we want to find the slope of the curve at that point right there. So this would be our point P with the coordinates a comma f of a. The way we do that is we're going to take this other point right here. We're going to find the slope between those two lines, and then the slope between those two lines and those two, and those 2 points, and get those points closer and closer and closer and closer together. Okay? So that's a formal definition of what we were doing when we were looking at the tables on your calculators and things like that. Okay? What? Go back?
No, okay.
So this is a problem that you guys did on your quiz. It's a problem that you did on your test. And the way we did it on those two things was by choosing points that were getting closer and closer and closer to 1, figuring out what the slope was, and then sort of estimating where that was going. Now we're going to do it based on the limit laws that Ms. Fowler taught you last week and come up with an exact answer. Okay? So in this case, what is A? 1. Okay. What is f of A? Also 1. And so what we are going to do is we're going to take the limit as x approaches, which is 1, as x approaches 1, of, if we go back to this definition, f of x. What's our function in this case? X squared minus f of a, which is 1 over x minus a, which will be x minus 1. So we're plugging in the actual numbers for the a's and leaving the x's and the f of x's as what they are. So this is going to be over x minus 1. So now instead of doing that whole thing where you go, okay, x1 is 1, y1 is 1, so then I'm going to choose an x2 that's 1.001, right? And doing that whole estimation thing. Now we can use this definition combined with our knowledge of limits to figure it out exactly. How do I evaluate that limit? Factor the top. Too soon. Too soon. Factor the top into x minus 1, x plus 1 over x minus 1, which allows us to cancel the x minus 1s, and then I can plug in the value of x directly and find out that my answer is 2, okay? So that means the slope of my tangent line to this parabola at this point is equal to 2, okay? So now I have, so this is essentially the slope. Now I have the slope, a point, and I do the old y minus 1 equals 2 times x minus 1 all again. Alright? So, piece of cake, right? Calculus is so easy. Okay. There is a little bit of a different way that you can look at this. The alternate definition of the slope of the tangent line, which sometimes makes the math easier, because you might notice that the only reason why this worked is because we were able to factor and cancel, but that's not always necessarily going to be the case. So there's another way that you can write it. You can take the point A, and then you can try and find a point really, really close to that, and then express the limit as, this means the distance between them is approaching 0, okay? So this other one, the way that it was written is you were taking the limit as the 2 points approached each other. This is basically the same thing, it's just rewriting it so you want the limit as the distance between them approaches 0. And sometimes that works out better, okay? So for example, you can do it either way. Let's this time have our equation be 3 over x, and our point be 3 comma 1. But only writing. Okay. Golf, right-handed.
No.
Baseball, football, right-handed. Not. Kick, right-handed.
You're right.
All right, left-handed.
How do you manage that?
Oh, shoot a basketball. Yeah. All right, so let's solve this using this other definition. So now I want to find the limit as h approaches 0 of what is my a in this case? 3, because it's the x coordinate of the point. So I'm going to go 3 plus h minus, what is f of 3?
Please excuse the interruption, but we want to let staff know that the internet is back.
Yay, we can stop learning now. Right? Find the derivative. What goes next? What is f of a? 1. That's the y coordinate. So like I said at the beginning, this is just a fancy way of doing the slope formula. Okay? y2 minus y1 over x2 minus x1, and the only difference here is that since we want it to be approaching 0, our x2 is always going to be 0, so all I have to put on the bottom is h. Okay, so that's my first step. What is f of 3 plus h? What?
What is h?
I don't know, but I don't really care. What I want to know right now is what do I get when I take 3 plus h and plug it into this equation right here? How about 3 over 3 plus h? Okay, so if I take 3 plus h and plug it in there for x, then that is 3 over 3 plus h minus 1 over h. So this is still the limit. I'm just being lazy and not writing down the whole limit thing. Now we get into some fun math. How do I go 3 over 3 plus h minus 1? What do I have to do? common denominator, and what will that common denominator be? 3 plus h, so this will be 3 over 3 plus h minus, very good, 3 plus h over 3 plus h, and that's all over h. There are h's running around like crazy. Well, let's simplify the top first. Be very careful as you do this. Tell me what you get when you simplify the top now that we have a common denominator of 3 plus h. Negative h. Okay? 3 minus 3 cancels 0. Don't say that therefore it's h over 3 plus h. This minus sign goes to both of those things, so I'm going to be left with negative h. Okay? And then this one here, Miss Fowler talked to you about that, the triple decker fraction. Do you remember the little trick you can do there? We're multiplying by the reciprocal, so we'll do it out longhand, and eventually then you guys will figure it out and do it quickly. So I'm going to multiply by the reciprocal 1 over h. What happens here? Those cancel. Okay, so I'm left with negative 1 over 3 plus h. But remember, this whole thing is the limit as h approaches 0. So now what can I do with the 0? Plug it in, and so my slope is negative 1/3. Yeah?
So these graphics are
At the same time.
Sure.
Leonardo da Vinci could do that. Start at the end, and I think he could do his name or something. He started at both ends with both ends at the same time.
That's not.
Well, you know, he was crazy. He was an artist and an inventor, and Ben.
So why are we using this equation and not the?
Just because we can. Let's do the same problem with our right hands using the other equation. So f of x was what? 3 over x? And the point was what? 1 and 3? Is that true? Oh, 3 and 1. Okay, so let's do the other one where we said the limit as x approaches a. Well, what's a in this case? 3. So the limit as x approaches 3 of f of x, which is 3 over x, minus f of a, which is 1, all over x minus a, which would be x minus 1. Okay? So we could do it this way, and then we could go through the same process. Get me a common denominator there, x. So this is going to change into 3 over x minus x over, x. Over x minus 1. How can I rewrite this on the top now that I have a common denominator? 3 minus x over x minus 1, right? Do I need to do all this, or could I just plug in 3?
That's ridiculous.
Oh, okay. I was going to say something wasn't working out there. Thank you. X minus 3. Sorry.
What?
Okay, right. Otherwise, it would have been an easy problem. Okay, so now I'm going to, like in the other problem, multiply by the reciprocal of the fraction on the bottom. So I'm going to go 3 minus x over x times 1 over x minus 3. And you can cancel these things, but instead of canceling out and equaling 1, since they're opposite, they equal negative 1. So I end up with negative 1 over x. And then you plug in the limit thingy, and you get negative 1/3. Which is what I got the last time, right? So it's just two different ways that you can do it. Sometimes it's easier to do it using one formula, and sometimes it's easier doing the other one, okay? Okay, so first question is, who cares? And so let me give you a reason to pretend to care. So sometimes we might be concerned about the average velocity of an object. That's a pretty easy thing to do, right? Distance divided by time, or displacement divided by time. And so the way that you could find the distance is, here's where it was, or here's where it started, here's where it ended up, and divide like that. But what this formula allows us to do is we can figure out what the instantaneous velocity of an object is. So by taking this regular old velocity formula and changing it so that the distance between the 2 points that you're concerned with approaches 0, instead of finding the average velocity at any point in time, you end up finding the instantaneous velocity, the velocity of the object at that particular point in time, which is a more powerful idea than just what your average velocity was. Because if you know your average velocity, there's still a lot of mysteries about what happened in between, right? I could say that I drove to the beach this weekend and my average velocity was 55 miles an hour, so I didn't break any traffic laws. But that's not necessarily true, right? I could have gone 30 miles an hour for a long time, and then I hit that straight stretch, and then I did 90. And then it just averaged out to be a legal thing. And now I wouldn't do that because I did that last year and got pulled over. The good news is it was Officer Green that pulled me over, so he just walked up and started laughing. So I was okay. I just have to deal with stuff in junior traffic class for the rest of the year, but it worked out. All right, so let's do a little thingy here. So we are going to, for some reason, climb to the top of the CN Tower. Does anybody know where that is?
What tower?
The CN Towers in Toronto.
Is that the one?
I think it is, yeah. CN. And we know that the CN Tower has to be in Canada because we know that it is 450 meters above the ground. Okay? And if it was in the United States, we wouldn't be measuring it in meters. So it's probably in Toronto. Okay? So we're going to climb up to the top and we're going to drop a ball off of the top. And then we're going to figure out some things about the flight of the ball. So the first thing is, does anybody know the equation for free fall from physics?
Like 10.
Right.
16.
But see, year 16 is in feet. And so we need to go meters per second, which isn't 10, but if somebody said 9.8, but it's half of that. So the position the position of our object at any time is going to be 4.9 p squared, okay? And this is a weird calculus thing that I have never understood. But they use the letter S for position, okay? V is velocity, A is acceleration. Do you remember this from college?
Not really.
Okay, they use S for position. I don't know why that's the case, okay? So let's do two different things. Let's find the average velocity after 5 seconds. And then let's find the instantaneous velocity of the ball when it actually hits the ground, okay? So first of all, the average velocity is the easy one. What is its, where was it when we started? So what's its initial position? You want to go 0, we'll make where we dropped it from the 0, that's fine. And what was the time when we dropped it? 0. What was its position 5 seconds later? How far had it fallen in the first 5 seconds? Huh? No. How do I figure that out? So you're pretty close to 125. Yeah, just plug in 5 into here, and that tells me its new position. Okay, what'd you get? 122.5. Okay, so what is its average velocity? How far did it fall? How far did it move? What's its displacement or its change in distance? You give me the final answer, right? Okay, so it started at 0 and then ended up at 122.5. So it moved a total of 122.5 meters. How long did it take to do that? Total of 5 seconds. So I just divide those two things and get what? 24.5 meters per second is the average velocity. Okay. Okay, so that's easy, right? Now let's find the instantaneous velocity when it hits the ground. And so now, since we're talking about instantaneous velocity, we need to do the limit thing. So the instantaneous velocity is the limit as h approaches 0, just like the other ones. But in order to do this, we need to figure out how long does it take for it to hit the ground. So they did this a different way. That's okay. Let's see if we can struggle through it and come out fine. How long does it take to hit the ground? Tower was 450 meters, and we know that it goes 4.9 t squared. So we just need to solve this for t. So we need to figure out how long it takes for it to go 450 meters, and we know that its displacement is 4.9 t squared. So how do I solve that for t? I would also divide by 4.9, and then I would take the square root. And so that tells us that it takes 9.6 seconds for it to hit the ground, okay? So I want to figure out the average velocity after 9.6 seconds, okay? So what am I doing here? So I'm going to go the limit as h approaches 0 of f of a plus h. What's my a in this case? This is 9.6 because we're trying to figure out the change in the time. So I need to take 9.6 plus h and do what with that? But this is this is my a. This is the time, right? Do that. That's not a big deal. So that's 4.9 times. What's the quick way to square a binomial? Anybody know? We'll all say it at the same time. Square the first and the second one. So 9.6 squared is, what is it? 92.16. Square the second one, so that's going to be h squared. And how do I get that middle term that kids always forget to do? Right, take this and double it. So that's 19.2h. Okay? Does that make sense? Kind of? Okay, or you could write it out and FOIL it out all the way there. Okay, so let's distribute the 4.9, and you're going to see some magic happen here. What's 4.9 times 92.16? The answer is already on the board, I believe, isn't it? 450. Well, we rounded a little bit, right? Okay, so this comes out to be 450, and that is not a coincidence that those came out the same, plus 4.9 times 19.2 is 84.08. 94.08, and that's h, right? Plus, I can do this one in my head. 4.9 times h squared is 4.9 h squared. So that whole thing was f of a plus h. Okay, so that's kind of a pain because our function was a little bit more complicated than the two examples that I did here, where this one, to plug it in, I just ended up with, 3 over 3 plus h. We actually had to do some math to figure that out. Okay, what is our f of a? What would I get if I put 9.6 into this thing right here? You should know that without doing any math. 450. That's where that came from. We set it equal to 450. Okay, all over h. Let me get this junk out of the way. The whole thing out of the way. Rebel. Okay, so what can I do to simplify the top? I can cancel out the 450s. And again, like I said, that's not a coincidence that that happened like that. So now I have the limit as h approaches 0. You guys want the ambidextrous thing of 94.08 h plus 4.9 h squared over h. What can I do now?
Take an H.
Take an h out of everything. There's an h here, there's an h here, and there's 2 of them there. So that leaves me 94.08 plus 4.9 h. And to figure out the limit as h approaches 0, I plug in 0 and get a final answer of 94.08 meters per second. Okay? So that was a little bit sloppy, but that's the basic idea. Okay? Yeah. Going fast. Okay, so why don't you try some of these on your own? And I'm guessing
Whatever you're dropping, that.
Just imagine that thing.
No, I thought you knew yours was what you're talking about.
And you get classmates get